Dirac function well. Hmm? I mean, look at here. This problem is for only for bound state. Is that okay? Pick up. Not for scattering state. Okay. I mean, bound state of Dirac function well. That's what I'm talking about. Pick up. Hmm. Huh. Hmm. Hmm. You can exactly apply the same thing. Once you estimate the ground state energy and ground state wave function, okay? Wait a second. Can you substitute back and find psi t? Psi t is equal to 2b by, what is that? Pi raised to 1 by 4 e power minus bx square. Am I right? What is b? M omega by 2h bar. Is that okay? Pick up. This is equal to 2 m omega by 2h bar by pi raised to 1 by 4 e power minus m omega by 2h bar x square. Am I right? 2 got m omega by pi h bar. Is that okay? That's exactly your ground state wave function. Okay? Pick up. Earlier problem. Now, once you find this one, okay? Now, if you want to estimate first excited state energy and first excited state wave function, so the next trial wave function, whatever you take for first excited state, that should be orthogonal to this. Because that is the logic, am I right? If this is the ground state wave function, first excited state wave function should be orthogonal to this one. You pick some function which is orthogonal to this one, which has a zero inner product with this one, and start doing the same thing. He mentioned one problem, okay? Well, after estimating the ground state, you can choose one orthogonal wave function, orthogonal to earlier trial wave function, and you can go for best estimation of the first excited state and first excited state wave function. Is that okay? Speak up. I mean, with all experience, okay? Speak up. For any other state, isn't it? But you try to do that step again and again. You try to minimize that one, so that is the next higher energy. I mean, the next state, whatever you take, whatever energy you get, that is always greater than this ground state energy, ground state estimated energy. Is that okay? Speak up. And I mean, if it is less than that one, that was the best trial wave function, isn't it? Speak up. And like that you do. That okay? You have to do some iterative steps actually. Is that okay? What we actually do is we make a computer program. We do input, okay, of different parameter, different function. Is that okay? So that it gives the estimation. So that again we modify that. Okay. So how do we take the trial wave function? We should have some experience. Okay. Usually in molecular structure, while finding the structure, they use this one. Is that okay? You can go for second derivative test to check whether it is maximum or minimum. Is that okay? Yeah. I mean, whatever the B we got, okay, whether that is a maxima or minima, isn't it? Because derivative is 0 in maxima as well as minima, isn't it? You go for check that one. I think you got only 2 points, am I right? 1 point is not possible. That's why I just took other point. Is that okay? Now I will go for this one. Okay, now I will choose trial wave function as a e power minus bx square, Gaussian trial wave function. Now this also solved problem. Okay, in exam they don't give you any unsolved problem. Okay, because you guys may choose different trial wave function, you will get different answer. How do they design question? Isn't it? They give some solved problem only, or they give trial wave function. You don't have to choose trial wave function. Is that okay? Or they may ask by giving the problem, what is the best trial wave function? You should apply all of your experience and logic to choose the best trial wave function. That's it. Is that okay? Speak up. So that's why they give the trial wave function so that our answers will match and you can choose the option. Okay. Now look at here. We already know this is not the exact wave function, am I right? For this bound state. What is the exact wave function? Speak up. E power minus some alpha mod x. Speak up. That is exponential. This is Gaussian. Both are different. That okay? We know that one. Now what you can expect here? You can expect slight deviation from the ground state. Is that okay? Look at here. Solve this one. So again, this normalization constant we already know. Again, the region of interest is minus infinity to plus infinity. Pick up. The region of interest is minus infinity to plus infinity. Is that okay? Quickly normalize. Psi of t, psi, I mean, we have already done that normalization, isn't it? Pick up. So shall I take? Hmm. So shall I take it? Psi of t is equal to 2b by 5 raised to 1 by 4 e power minus bx square. Is that okay? This is a normalized state. Speak up. Are you there on Google Meet? Speak up. Can you hear me? If there is no reply, I will feel like you kept video on and you went for sleep. You have taken the same trial wave function. Expectation t is same, isn't it? Pick up. Are you done? I mean, you need to find expectation h in this t. That's equal to expectation t in this one. Expectation plus expectation v in this one. Isn't it? Pick up. Now expectation t is same because again this p square by 2m because this operator will not change. Am I right? You have taken the same trial wave function, same normalization constant. Okay. That's why expectation of this one is same as earlier. Can I write directly? Pick up. Because this operator will not change. What is changed? Only this one. Isn't it? That's equal to h bar square by 2m into b. Isn't it? Pick up. Now expectation v you need to do. Isn't it? Expectation v you need to do. What is this one? Psi star minus alpha delta of x psi dx, isn't it? What is this one? 2b by pi raised to 1 by 2, okay, minus alpha delta of x multiplied with e power minus 2b x square dx, speak up, minus infinity plus infinity. Dirac delta will choose the function at x equal to 0, isn't it? Speak up. That's equal to minus alpha 2b by pi raised to 1 by 2 into 1. Am I right? Check this out. It's equal to expectation v is equal to minus alpha times under root of 2b by pi. B is my variation parameter. Expectation h at t, that's equal to, when you add these two, h bar square b by 2m minus alpha, I'll write under root of 2 by pi under root of b, because I need to take derivative with respect to b, isn't it? It's a function of that variation parameter. Dirac delta will choose the function at x equal to 0. Speak up. Property of Dirac delta. Dou h by expectation h by dou b equate to g. That's equal to h bar square by 2m into derivative of p equal to 1 minus alpha root of 2 by pi. What is root b derivative? 1 by 2 root b? 1 by root b, 1 by 2 root b. Speak up. That's equal to alpha root of 2 by pi 1 by 2 root b, that's equal to h bar square by 2m. Okay. Root b is equal to 2m alpha by h bar square. Speak up. Root b is equal to 2m alpha by h bar square into root of 2 by pi 1 by 2 1 by root 2 pi root 2 by 2, that is 1 by root 2. You can write as 2 got cancelled. Okay. Root of 2 by 5 1 by 2. Yeah, these two got cancelled. Okay. That's equal to root b is equal to, look at here, m alpha by h bar square under root of 2 by pi. Am I right? Speak up. B is square of that one, isn't it? B is square of that one. Now what is expectation H minimum? Speak up. H bar square by 2m square this one. Square this one. B. Okay. M square alpha square divided by H bar raised to 4 into 2 by 5. So check this out. Minus alpha root of 2 by 5. Okay. Root of 2 by 5 multiplied with root b m alpha by h bar square into root of 2 by 5. Check this out. H bar square m alpha square divided by 5 h bar square minus 2m alpha square divided by 5 h bar square. Check this out. Root to 2m alpha square divided by 5 h bar square. What is this one? Minus m alpha square divided by 5 h bar square. That's the best estimation. That's bound state energy is negative, right? Pick up. What is the exact energy? What is the exact ground state? Ground state means bound state. Okay, pick up. Pick up minus m alpha. No, I mean we have written minus some h bar square, some kappa square by 2m. What is kappa? Kappa is equal to. You have to remember that when I told you, am I right? While solving MCQ, they are expecting. Okay. Check that out. I need exact. Pick up. This is the best estimation we got. Okay, we shall compare with this exact ground state. Okay, that's equal to minus m alpha square divided by 2 h bar square. Energy. Yeah, this is the exact energy, isn't it? Speak up. Bound state of what do you call Dirac function. Well, pick up. Now look at here. These two are not much different, isn't it? But they are not equal. Am I right? Pick up. We got some error here. Now look at here. Magnitude of this one is less than this one. Pick up. This is zero energy. Suppose. Okay. This is zero energy. So this is what you call minus m alpha square divided by 2 h bar square. Okay. Here you have minus very near actually. Very near. Okay. You have minus m alpha square divided by 5 h bar square. If denominator is high, the magnitude of that one is low, it will move towards zero, isn't it? Pick up. This is higher than this one. Are you getting it? Pick up. Because it's in the negative values. And look at here, it is not too much deviating from this one, am I right? It is not exactly equal to this one, okay? But it's the best estimation actually. And it's not deviating too much, isn't it? Pick up. You are not getting out of order, am I right? You are not getting any 10 to the power order or something. Here you have 2, here you have 3.14 or something. Isn't it? Now, again, this is not exactly equal to this one. It is deviating. It is not deviating much. Why? It all depends on, look at here, your wave function. Your exact wave function is like this. Am I right? Pick up. So this is psi ground state. Exact. Pick up. It is like this. E power minus alpha mod x. But the trial wave function, whatever you have taken, okay, that is like this. Figure e power, so trial wave function, e power minus bx square. Are you getting fine? Not much different, but again, not equal. They are not equal. Is that okay? Speak up. They are not equal. Are you getting fine? They are not equal. Your trial wave function That differs from the actual one. If you know actual one, you don't solve the problem at all, isn't it? Figure. So the trial wave function that deviate from ground state, okay, but it will not deviate much, okay, it deviates slightly, am I right? Speaker. Are you getting my point? The shape of the curve is not what you call too much deviating from that what you call earlier curve. That's why your what you call estimation is not deviating too much from the exact ground state. If whatever the trial wave function you have taken, if that is too much different from this function, okay, pick up, then this error will also be large. Is that okay? Observe the compare it with the exact one and observe the error, how much error we get, and compare the wave function. Okay, you will have some understanding. Accuracy of estimation depends on. Okay, can you write down? Accuracy. Accuracy of estimation. Accuracy of estimation depends on how close psi of t to psi gs exact. I mean, because we are dealing with a problem which is already solved, isn't it? Speak up. We are dealing with a problem which is already solved. We know this one, isn't it? So that's why whatever the trial wave function they give, we can compare, am I right? With the exact ground state, we can say, yeah, this is close to that one. That's why answer will be close to ground state. Like that, you can have something. Okay. The accuracy of the estimation depends on how close psi of t to this one. If the psi of t is very similar to this function, okay, that accuracy is more. Now, what I am saying is in our whole algorithm, okay. Actually, I didn't do this one at all. Yesterday also, today also. This is the time consuming part. Is that okay? Speak up. This is the time consuming part. Okay, speak up. So that's why what I would suggest is, okay, speak up. I mean, if you want to attend this question in exam, you better to remember this. Some trial wave function and its expectation t. Because t will not vary, am I right? It's always p cap square by 2m minus h bar square by 2m d square by dx square. This won't vary, isn't it? Speak up. This operator. Potential varies depending on the system. So that's why what I'm going to do is I'm going to list out some trial wave function, okay, pick up, and corresponding expectation t. And it is not so big deal. You will understand this one, okay? I will tell you how I got these things, okay? Some trial wave functions, some famous trial wave function, uh, except one or two, all trial wave function, whatever they gave in exam, in book, they are these things only. Speak up. Are you getting it? Except one or two. Speak up. Some trial wave function and respective expectation t. Okay, speak up. Expectation t in the trial wave function. Okay, speak up. So first one, okay. If our trial wave function, it is like this. Okay, speak up. A sine phi x by a when x is between 0 to a, 0 otherwise. What would you think? Expectation t. What energy?
1D.
Yeah, in 1D box, expectation h is nothing but expectation t. Pick up, and this is the ground state wave function, 0 to a particle in the box. Look at here, they can give this trial wave function for harmonic oscillator. A is a variational parameter. Are you getting my point? They can give this trial wave function for harmonic oscillator. I will say potential is like this, wave function is some sinusoidal and it is 0 outside. I will say like this. I will guess like this if I don't know exact solution. Speak up. Are you getting my point? But expectation t part remains the same. Expectation v part depends on what system that they have given. Okay, I don't think they will give this one and 1D box as your system, you will get the exact answer. Is that okay? We have seen, am I right? Pick up. If trial wave function matches with exact ground state of our system, then we will get the exact answer. Okay, speak up. So they can give the system anything. Okay, speak up. But your expectation t in this case, that's equal to pi square h bar square by 2m square. Now here, if suppose harmonic oscillator is our system and this is our trial wave function, a will become variational parameter. Is that okay? Speak up. If you have to take derivative with respect to a and all. Is that okay? Speak up. Second one. I hope this is not a big deal to prove. If you take expectation value, 0 to a, you need to integrate. Take normalize this one. Sine becomes sine only. Use that normalization factor. You can prove pi square h bar square by 2m square if you wish to do that one. It's not a big deal. Speak up. But what I'm saying is I'm comparing it with our 1D box problem and I'm evaluating this one. That's the best way. But don't write again expectation v equal to 0 or something. I'm saying this is the trial wave function. I'm not defining the system at all. They can define system anything, potential anything. Is that okay? I'm just listing out trial wave function, expectation t. I hope this is not a big deal to remember. Okay. If our trial, I mean, this is the best trial wave function for harmonic oscillator. Let me tell you. Okay. A cos pi x by a. Okay. Pick up. Because that potential is symmetric. Am I right? Pick up. When x is between minus a by 2 to plus a by 2. Okay. Pick up. 0 otherwise. This will make a good trial wave function for harmonic oscillator. Is that okay? Now, in this case also, what is expectation t in this trial wave function? Speak up. Pi square h bar square by 2m square. Isn't it? This is a ground state of symmetric one. This will make a good trial wave function for harmonic oscillator. Because symmetric, this state is symmetric. Okay, speak up. You may get answer nearby h bar omega by 2. That's what I'm guessing. Okay, pick up. So third one is frequently used trial wave function, that's equal to a e power minus b x square. X is between minus infinity to plus infinity. Okay, speak up. Now look at here. You need this one. You need its range of interest to find expectation t. You don't need anything else. Am I right? Speak up. In expectation t, what you do? Psi star psi sandwiching between d square by dx square. You just need this thing. Okay. Now, how did I find this one? By comparing this one with the ground state of harmonic oscillator. Speak up. That will be h bar square by 2m into b. Speak up. How did I find this one? Speak up. So e power minus bx square, I'm comparing it with e power minus m omega by 2h bar x square. Okay. For this one, okay, pick up. Your expectation t will be, do you remember? It's a ground state. H bar omega by 4 actually, half of ground state energy. Do you remember expectation v is equal to expectation t in case of nth stationary state of harmonic oscillator, that's equal to En by 2. Recall Varial theorem. Okay, speak up. So that's why it is h bar omega by 4. Okay, speak up. So when I compare these two, okay, speak up. Now what I should do is, okay, for this one, this problem was there earlier. I think I told this technique. Am I right? This problem was there, just problem or something. Okay, speak up. Now let h bar be there, m also be there. Okay, pick up. But you need to avoid omega. Am I right? Pick up. Or if b is equal to, pick up, m omega by 2 h bar. Okay, then omega is equal to 2 h bar b by m. Am I right? Pick up. So then h bar by 4, omega will replace. Okay, speak up. 2 h bar b by m. Is that okay? Speak up. What it will be? H bar square b by 2m. Am I right? Pick up. That's what I have written. Now look at here. They may give this wave function. They may ask you find expectation t, some other problem, quantum mechanics problem. Then you can compare it with this one. You know this one. You can quickly do this one. You don't have to do that integral at all. Are you getting point? Only this parameter is changing. That's it. Okay, you should know. I mean, what parameter that you need to change? H bar universal constant that will be there, am I right? In expectation t, h bar square by 2m is there, mass is there, but omega is different here, am I right? You need to, what you call, change that omega. Is that clear? Speak up. So this is how I found this one actually. Or I mean, you do it for one, you do this one, this expectation t one time, and you remember that one. Okay, speak up. Now look at here. This is very simple. Fourth one, if trial wave function is a e power minus bx only. Now this is not normalizable in the negative infinity. In negative infinity, this will diverge actually. In this case, your x will be 0 to infinity. Only in this region, this is normalizable. Okay. I mean, if they mention this as your trial wave function, usually our range of interest will be this one. Are you getting my point? Speak up. In this case, your expectation t, okay, speak up, that's equal to h bar square by 2m into b square. How I did this one? I compared this one with hydrogen atom ground state actually. Let me tell you later. Or you do it once. 0 to infinity, okay, speak up. Otherwise, it's not normalizable. When x goes to minus infinity, e power minus of minus infinity diverges, okay, speak up. It is normalizable only 0 to infinity, okay, speak up. Now, fifth one, another famous trial wave function, a e power minus b mod x. Can you tell me? Here x can be minus infinity to plus infinity, am I right? Speak up. Now I compared it with eigenstate of, I mean, ground state or only one eigenstate, am I right? In case of Dirac function value, okay, speak up. And I found expectation t, okay, this is also equal to, I think, h bar square by 2m. Remember, here comes one problem. This has a derivative discontinuity. You can't take second derivative while finding expectation t. Speak up. First derivative mod square, that technique we need to explore. This has a sharp edge, am I right? Second derivative doesn't exist. Or if you want to do second derivative, you need to use Dirac delta. Are you getting my point? This function doesn't have second derivative. First derivative is discontinuous. That amount of discontinuity we found in the second chapter, recall that one. While doing this one, don't take second derivative, okay? Pick up. Take first derivative, make it mod square and all, okay? Pick up, if you wish to prove. Hmm? Hmm.
X is tending to 0, psi t is not tending to 0.
Need not be.
But wave functions should tend to 0 at the
That's right. That's right. But wait a second. Let us see. I don't know. I mean, they can give trial wave function which may be worst in some case. Speak up. But it should be continuous. That's what you are saying. It should be defined in x less than this one. Yeah, that's right. Yeah, I didn't see this trial wave function anywhere, but I saw similar one. Let me define now. Okay, speak up. Now, I mean, sixth one is equal to ax into e power minus bx. Yeah, this is feasible. It is 0 at x equal to 0. Okay, this was there in one of the problem. Okay, speak up. X is from minus infinity to plus infinity. These are bit simple. Okay, I mean, if you solve all problem using this one, okay, couple of times, then you will remember this thing. It's not a big deal. Okay, again, expectation t, surprisingly it is same. B square, same as this one. I don't know how it happened, but you can check that out. Is that okay? Speak up. Now I will go for 2D. Sometimes they may ask 2D example also. Okay, speak up. With the number seventh one. If trial wave function is equal to a e power minus b x square plus y square, it's a 2D Gaussian. Can I say like this? A e power minus b r square. Speak up. So here actually r is between 0 to infinity actually. X and y between minus infinity to plus infinity. Okay, speak up. Or you better write that one. Okay, speak up. X comma y, they are between minus infinity to plus infinity. This r means plane polar coordinate r. I'm talking about 2 dimension here. Okay, pick up. Now in this case, expectation t is okay 2 times h bar square by 2m into b. H bar square by 2m into b was when it is in 1 dimensional Gaussian, 2 dimension 2 times, 3 dimension 3 times. Easy to remember. That's what I'm saying. Okay, speak up. I need this one. Okay, speak up. In case of 3D, okay, psi t is equal to a e power minus b x square plus y square plus z square. I don't have any 2D problem, but I have 3D problem. Okay, again here x, y, z ranging from minus infinity to plus infinity, or you can write it as a e power minus b r square. R is running from 0 to infinity. Wait a second. You need to write theta running from 0 to pi, phi running from 0 to 2 pi. It is 3D only. Problem is 3D only. Okay. In case of 3D problem, they can give this one as a trial wave function. There is one question. Hydrogen atom is our system. E square minus E square by 4 pi epsilon naught R is our potential. This is our trial wave function. Estimate the ground state. It will not be so bad. Our answer will be close actually. Okay, speak up. So, ninth one. Wait a second, I didn't write what is expectation t. Expectation t, in this case, it will be 3 h bar square by 2m into b. So this will save a lot of time, okay, speak up, while solving especially this problem, because it is very time consuming. Speak up. Ninth one. So if your trial wave function, how you can find this one? Can you guess? This is a ground state of 3D isotropic oscillator. You compare it with its expectation. 3D isotropic oscillator. You can find this. Is that okay? Speak up. So if psi t is equal to a e power minus b into r, usually we handle r is between 0 to infinity. So theta is between 0 to by 3D only. Okay, this is also 3D only. 3D only. Okay, speak up. Hmm? No. Be careful. Be careful. That won't work. Okay, speak up. 0 to pi. Surprisingly, this is h bar square b square by 2m only. No 3 or something. 0 to 2 pi here. 0 to 2 pi here. Are you getting this idea? So that will save a lot of time, because look at here. This contains second derivative, or if you use that technique, you can make it first derivative. You can't avoid that. And after that, you need to take integral. Okay, speak up. If you save this time, you can put your energy in further part. Am I right? Speak up. List out this trial wave function. Wait a second. I will look into this one again, because if you write any mistake again, you will end up with trouble. Am I right? 1 second. 2ma square cos pi x by a. You guys better to logically argue all of this one actually. Okay, then no mistake will happen. Bx square. This is also right. Okay. Bx, yeah, b square here. So this was very much required actually. This fifth one. Why? Because first derivative will have different. You have to define mod x as minus x when x less than 0, plus x when x greater than 0. You need to take derivative in the negative x, positive x separately. You need to split your integral. Pick up. Bit of effort here. Even if you wish to write it as first derivative mod square, it takes some effort actually. Okay, speak up. I think this problem was there in after your Dirac function well problem. Okay, speak up. They asked expectation p square or uncertainty. Okay, speak up. While finding uncertainty, you need expectation p square. There, I think I have used this one. Just recall. E power minus kappa mod x. h bar square kappa square by 2m. I told with positive sign. That is your expectation t. Speak up. I told you to remember that. Is that okay? X into this is also b square. This is also b square. That's right. So b 2D we don't use much. Okay, speak up. Let it be. Okay, 3D 3 h bar square by 2m into b. That's right. B square by 2m. That's also right. Okay, speak up. V of x is equal to second one. Okay, V of x is equal to speak up. That's equal to k into x when x is greater than 0, infinity otherwise. Is that okay? That's equal to infinity otherwise. Now this is the situation where you can imagine physically. Suppose this is a floor, okay, and this is positive x-axis. This is origin x equal to 0. This is negative x-axis. Is that okay? Speak up. And you are dropping a ball here. Okay, it's going to bounce on for something. Is that okay? Speak up. So then you have gravity like this. Am I right? Speak up. If you have a mass m here at a distance x from the origin, this is positive x-axis. Okay, its potential energy is equal to speak up mg into x. Speak up. And it cannot penetrate into the floor. That's why potential is equal to infinity here. Potential equal to infinity here. Potential is equal to mgx above, isn't it? Speak up. So can I write like this? V is equal to infinity here. V is equal to mg into x above, isn't it? Speak up. That's same as this. V equal to k into x when x is greater than 0. V equal to infinity. The same problem they can design like this. The same problem they can design like this by sentence, isn't it? Speak up. So now the trial wave function is, look at here, psi is equal to ax into e power minus alpha. Alpha into x. Okay, alpha is missing there. In the question, alpha is missing there. Okay, e power ax e power minus alpha x. Okay, alpha is missing there in the question. Okay, just rewrite that one. Now estimate the ground state using this trial wave function. Now this trial wave function is quite feasible. Look at here. Plot the potential actually. Plot the potential V of x. Okay, that's equal to k into x when x is greater than 0. That's equal to infinity when x is less than 0. Am I right? Infinity here. K into x. That's equal to linear term, isn't it? Since potential is infinity here, okay, your wave function should 0 at x equal to 0. Okay, when you put x equal to 0, your wave function is 0, isn't it? In the region x from 0 to infinity, it should be normalizable. This is normalizable. You just integrate in the region 0 to infinity. Is that okay? This is normalizable. So again, so this is the potential. Potential is the situation. Potential defines the problem. Trial wave function is given. You have to estimate the ground state using variational principle. Okay, using variation principle. That should be mentioned in the question. Isn't it? Estimation. You have many other approximation theory. Speak up. But once trial wave function is given, that is variation principle. Okay, speak up. So first thing is normalize. What is step one? Speak up. Normalization. Mod a square. Speak up. Integral 0 to infinity. Okay, speak up. This is from 0 to infinity. Okay, trial wave function. Actually, you have to define trial wave function like this. That's equal to x into e power minus alpha x from 0 to infinity. Infinity is equal to 0 otherwise, but we don't quote that one. Wave function should be 0 in this region, or this region is not our region of interest, or particle cannot exist here. Is that okay? Pick up. We don't quote it here. And in the region 0 to minus infinity, this is not normalizable at all. When x goes to minus infinity, e power minus of minus infinity plus infinity. Okay, alpha is positive constant. Is that okay? Alpha is positive constant. Okay, speak up. 0 to infinity, x square into e power minus 2 alpha x dx is equal to 1. Okay, mod psi square. Pick up. Mod a square. What is this one? Gamma of 2 plus 1 divided by 2 alpha power 2 plus 1. Pick up. X power n e power minus ax. Okay, dx. That's equal to 1. Mod a square. Pick up. What is this one? Gamma of 2 plus 1 is 2 factorial. 2 divided by 2 cube into alpha cube. Am I right? Take this out. Or do it yourself along with me. So 4 alpha cube. Am I right? A is equal to 2 square into alpha cube, mod A square. A is equal to 2 alpha power 3 by 2. Pick up 2 alpha power 3 by 2. That's your normalization factor. Check this out. Okay, do it yourself. If I'm wrong, quickly tell me. Okay, that saves our time. That's equal to 2 alpha power 3 by 2, okay, into x e power minus alpha x, okay, psi of t. What I do is I'm going to take a only in the calculation. Later I will substitute a equal to, pick up. I'm going to remember this one, okay. A is equal to 2 alpha power 3 by 2. Because, I mean, writing a 2 alpha power 3 by 2 every time is quite lengthy, okay. But while writing last Hamiltonian, okay, I need that one because I need to take derivative with respect to this variational parameter. Isn't it? Now, what is the next one? Expectation t. I already told that one. For this kind of trial wave function, you should remember expectation t directly. So h bar square by 2m into alpha or alpha square. Alpha or alpha square. Alpha square. For Gaussian, it was h bar square by 2m into this one, isn't it? Only alpha. Check that out. I'll give one. Because this consumes time. Okay, this step consumes time. Finding expectation. Is that okay? Pick up. So for the trial wave function, okay? Finding expectation v is not a big deal. Is that okay? Pick up. So that's equal to, so mod a square integral 0 to infinity. What is this one? Kx into mod psi square. That's equal to x square e power minus alpha x dx. Isn't it? Pick up. I have written directly. Check this out. Somebody please do it parallelly yourself. Tell me if I'm wrong. Okay. Mod a square minus 2 alpha x. 2 alpha x. Is that okay? So into k 0 to infinity x cube will come. X cube into e power minus 2 alpha x dx. Isn't it? This is equal to k into mod a square. What is this one? Gamma of 3 plus 1 whole divided by what is this one? 2 alpha power 3 plus 1. Speak up. So that's why expectation V would be K into mod A square, okay, or mod A square into K. What is mod A square? 4 alpha cube, okay. 4 alpha cube is mod A square, okay, into K. Gamma of 3 plus 1 is 3 factorial, 3 into 2, okay. So 2 power 4 multiplied with alpha power 4. So 2 power 1, 2 square, okay, 2 power 3, 2 power 4 here. Is that okay? So what is this one? 3k divided by 2 alpha. Do it yourself and tell me, okay? Am I right? Is this the potential? Then expectation of Hamiltonian in this trial wave function state, that's equal to h bar square alpha square by 2m, okay, plus 3k divided by 2 alpha. Speak up. Expectation? Why? Expectation t will never be negative. Why? Minus h bar square by 2m? No, no, no. Some derivative and all, some more negative sign will. Is that okay? Because p square, am I right? I mean, just check that out. That's related to p square. Square of the linear momentum, measurement, average, how it can be negative? So, but look at here, while finding expectation t, I told you should use this one, h bar square by 2m plus, okay, integral, okay, mod of d psi of t by dx the whole square dx, okay, region of interest, isn't it? Not, I mean, again, using that Hermitian conjugation, we have changed, isn't it? Pick up. Use this one, positive here, okay? If it is minus h bar square by 2m, this is psi star, second derivative psi. Is that okay? Pick up. Use this one. Suppose if you wish to use this one, but I suggest you to remember those trial wave function, okay? Whatever the list I have given, because it is same, am I right? I mean, it's very easy to remember that logic, isn't it? For Gaussian, it is h bar square by 2m into this factor, am I right? For Gaussian 1 dimension. Gaussian 2 dimension, 2 times will come. Gaussian 3 dimension, 3 times will come, isn't it? and another one is exponential. One is Gaussian trial wave function, another one is exponential. For exponential, square root came, isn't it? Isn't it? Figure. Very simple to remember. Okay, just list out that one. Now, what is the next step? Speak up. Take derivative of expectation h by dou alpha equated to 0. Find alpha. Is that okay? That's equal to h bar square 2 alpha divided by m. Okay, 2 got cancelled. Minus 3 by 2, 3k by 2. 1 by alpha square is equal to 0. Check this out. Minus 1 by alpha square. 3k by 2 minus 1 by alpha square. Okay, so that's equal to h bar square alpha by m. That's equal to 3k divided by 2 alpha square. Okay, alpha cube is equal to 3km divided by 2 h bar square. 3km divided by 2 h bar square. Check this out. Pick up. 3km divided by 2 alpha square. Speak up. So that's why expectation h minimum. This is the best estimation of the ground state energy, isn't it? That is equal. Look at here. I told you this step would take time. Am I right? Look at there. So you h bar square by 2m. Okay. Alpha square. What is alpha square? Pick up. Alpha you need. Am I right? Alpha is equal to pick up 3km divided by 2 h bar square raised to 1 by 3. Isn't it? What is this one? Is equal to 3km divided by 2 h bar square raised to pick up 2 by 3. Am I right? Alpha square of alpha, isn't it? Pick up. So that is plus look at here, 3k by 2 multiplied with 1 by alpha. 1 by alpha is, can I write 2 h bar square divided by 3km raised to 1 by 3. Now look at the options. This is not in there any option. Is that okay? 2 by 3 can you write as 1 minus 1 by 3? 2 by 3 is 1 minus 1 by 3. Speak up. 1 minus 1 by 3. Is that okay? Speak up. So that's why this equal to h bar. Again, you do in your way. Okay, this manipulation. Okay, if you find some other way, you do it in what you're thinking. That's also okay. But look at here. What I'm doing is 2 by 3. I'm writing 1 minus 1 by 3. Okay, raised to 1 raised to minus 1 by 3. Is that okay? 3km by 2 h bar square raised to 1. Okay, raised to minus 1 by 3 can be flipped over again, isn't it? You can write 2 h bar square divided by 3km raised to 1 by 3. Is that okay? Okay, so a raised to 2 by 3, a raised to 1 minus 1 by 3, a raised to 1 into a raised to minus 1 by 3, that I flipped again. Is that okay? Speak up. Or do it again yourself. Okay, speak up. So plus 3k by 2, okay, 2 h bar square by 3km raised to 1 by 3. Now we can take that one outside, isn't it? Speak up. So 2 h bar square divided by 3km raised to 1 by 3, you can take it outside. Okay, so h bar square got cancelled. Okay, m got cancelled. 3 by 4k, 3 by 4k, okay, plus 3 by 2k. Check this out. What is this one? What is this one? 9 by 4. Speak up. 9 by 4k. 9 by 4k 2 h bar square by 3km over 1 by 3. 3 by 4 plus 3 by 2, that's equal to 4. 3 plus 6. Yeah. 9 by 4. If it is not in the option, try to manipulate it again, because I think I might have manipulated that one. Okay, this is the estimation of the ground state. Okay, pick up. Expectation h minimum, what I got, speak up, 9 by 4 k, okay, or 2 h bar square divided by 3k into m. Am I right? Raised to 1 by 3. Now you have k inside that one. Am I right? Pick up k inside. If you take k inside, I don't know whether you get it or not. Okay, speak up. I might have manipulated the option. Okay, 9/4. When you take k inside, it will be k cube. K raised to 1 by 3 or k cube raised to 1 by 3. Take it inside. Okay, then it will be 2 h bar square k square divided by 3. I mean k cube divided by k. Okay, 3m raised to 1 by 3. Do you have this option? Option 1. 2 h bar square k square divided by 3m 9 by 4 raised to 1 by 3. Okay, k is taken. This step takes time actually. Speak up. Can you execute it? Is that okay? Which one? This kind of manipulation. I mean, this kind of question, kx or mod x, or harmonic oscillator, isn't it? Yeah, this kind of step is quite common. Oh, what is the other way you told? Okay, you can invert this term. If you invert, I mean that will be raised to minus 1 by 3, am I right? Take raised to minus 1 by 3 common, then other term you can work it out. Yeah, that's also. Is that okay? Do this problem. Now I'll ask you one question. I'll take V of r, that's equal to minus e square divided by 4 pi epsilon naught into 1 by r. Okay. I take trial wave function that's equal to a e power 3-dimensional problem. Okay. A e power minus b into r. What is the energy you get? I take an hydrogen atom. Okay. I take a trial wave function like this. What is the estimated ground state energy? Pick up. I'm waiting on Google. Means you haven't solved the problem, whatever so I solved again. What is this trial wave function? Pick up. What is this function? Have you seen anywhere? Ground state, isn't it? If you take ground state as a trial wave function, what would you get? You get no error, isn't it? Pick up. You will get expectation h minimum is equal minus m by h bar square. What is that one? E square by m by 2 h bar square n equal to 1. This ground state of hydrogen, ground state energy, isn't it? Pick. What is the very first problem I have done? Validation. Validation of the theory, isn't it? Pick up. I have taken the known problem. I have taken exact ground state wave function. Okay, then I got exact answer. Exactly the same thing. 3-dimensional. Can you do it? Prove this. 3-dimensional problem. Okay, while normalizing and all, you have to integrate with respect to d tau volume element. Is that okay? Pick up. While finding expectation v of r also. Is that okay? You have to integrate in the 3-dimension. Can you do it? Prove this one. Is that okay? Prove this one. Take this v of r, take this trial wave function, prove this one. Is that okay? Speak up. Now I'll take hydrogen atom. That's the next problem. Okay, v of r, that's equal to minus e square divided by 4 pi epsilon naught into 1 by r. Is that okay? Speak up. The next problem, whatever I mentioned there. Okay, psi of r is equal to a e power r vector, actually r theta phi, but it's a function of only r. A b r square, 3-dimensional Gaussian function. Then you can expect some small error, am I right? Pick up. So that e power minus r with respect to r, okay, this e power minus br, it will go like this actually. That e power minus br square, r is always positive, radial distance, okay? It will go like this. It was bell-shaped curve, isn't it? Pick up from 0 to infinity. So not bad, isn't it? The trial wave function is not so bad. That's why you get answer very close to that one. If you just check out the options, if all answers are, I mean, if only one answer is close to ground state, hmm, I think you may able to eliminate the option. Check that out. I don't know. No, I mean, I might have given options confusingly only. Okay, you better solve it. Minus m by 2 h bar square. Okay, what is this one? E square divided by 4 pi epsilon naught the whole square. 3 by 8 5. That's one option. Okay, speak up. Uh, Minus m by 2 h bar square e square divided by 4 pi epsilon naught the whole square. This is one of the options. This cannot be. Why? You will never get exact energy because our trial wave function is deviating because this is a known problem. All right, speak up. This cannot be. This is option 1, option 2, option 3. Check that out. Okay. So it cannot be less than the ground state. Okay, speak up. This factor cannot be greater than 1. If this factor is greater than 1, this is negative value. It will be less than the ground state. Remember, okay? Remember, this is the exact ground state energy. Am I right? Multiplicative factor can never be greater than 1. Look at that. 8 by 3 5. Two option contains 8 by 3 5. Fourth option contains 8 by 5. 8 by 5 is greater than 1. Either option 1 or 3. Why two option contains? No, 8 by 3 5, 3 by 8 5. Okay, 8 by 3 5, 3 by 8 5. Both are less than 1. But at least you can eliminate some of the option. M by 2 h bar square, e square divided by 4 phi epsilon naught. What is this one? 8 by 3 phi. Fourth option minus m by 2 h bar square. Okay, e square divided by 4 phi epsilon naught. Check this out. 8 by 5. This is greater than 1. If this is greater than 1, this is in the negative value. Are you getting it? Modulus is greater than 1 or greater than this one means this is exact ground state energy. This cannot be because our trial wave function is not exactly same as ground state wave function. You should have some error. Speak up. So that this cannot be. Why? This is less than the ground state energy. So among these two, isn't it? Speak up. 3 by 8 phi. This is too low. What is this one? 8 by 9. This is close. So let us see. Okay. You guess option 3 because our wave function is not deviating much from the exact ground state. Am I right? What is this value? 1 by 8 into 3. 1 by 20. 8 into 5. Okay. 3 1 to 3. 1 by 8, isn't it? 1/8. Am I right? 1/8 of the ground state. This is nearly equal to 1 by 8 by 9 kind of thing, isn't it? We guess this one. Am I right? Because that should be less error. Don't know. We shall check that out. Okay. We need experience here. Okay. But don't gamble. Okay. In the exam. So first you need to normalize mod a square. Speak up. Integral. E power minus 2b r square dr sine theta d theta d phi. Speak up. Is equal to 1. Speak up. Mod a square integral of d theta d phi sine theta d theta d phi. That's one part. Okay. So integral 0 to infinity radial distance. Okay. R square into e power minus 2b r square dr. Am I right? Speak up. What is this one? 4 phi. Mod a square. Speak up. Mod a square into 4 phi. What is this one? X power n into e Gaussian. That's equal to 1 by 2 into 2b power 2 plus 1 by 2 gamma of 2 plus 1 by 2. Check this out. Integral 0 to infinity x power n into e power minus ax square dx. This formula. Speak up. Not gamma function. Okay. Gaussian instead. Speak up. That formula, that whatever I have planned. Okay. Speak up. Is equal to 1. What is this one? Mod a square into 4 phi divided by 2 1 by 2 power 3 by 2 b power 3 by 2 gamma of 3 by 2. Am I right? Gamma of 3 by 2. 3 by 2 can be written as half gamma half. What is gamma of half? Root pi. Am I right? Pick up. This equal to half. Gamma half is root pi. That's equal to 1. Mod a square. Pi into root pi is pi power 3 by 2. Pi by 2b power 3 by 2 is equal to 1. Okay? Pick up. A square is equal to 2b by pi whole power 3 by 2. I need a square everywhere. Mod a square is equal to 2b by pi whole power 3 by 2. Check this out. If you got something else, quickly tell me, okay, on YouTube or Google Meet if you are doing it parallel, okay? Speak up. Now look at here, expectation T, I told you, take it directly, am I right? This is three-dimensional Gaussian. I think I told you 3 into h bar square by 2m into b, coefficient of r square, am I right? If I can remember, that means you can remember. Is that okay? I mean, I remember from logic, okay? Not by practice, okay? Logic is one dimension, this one into one dimension Gaussian, okay? When trial wave function is one dimension Gaussian, two dimension Gaussian 2 times, three dimension Gaussian is like this. Is that okay? Speak. So expectation V, this one you need to do. Mod a square, speak up, integral minus e square divided by 4 phi epsilon naught 1 by r e power minus 2b r square into r square dr sine theta d theta d phi. Is that okay? Speak up. This is mod square of the wave function, okay, into potential. You have to sandwich, but it's operator is itself. Right? Speak up. That's equal to mod a square. What is this one? I'll keep mod a square. I will substitute later. That's equal to in minus e square divided by 4 phi epsilon naught. Okay, 1 by r integral 0 to infinity r power 1 e power minus 2 b r square dr. Am I right? Into integral of sine theta d theta d phi. Check this out. Pick up. Minus mod a square e square divided by 4 phi epsilon naught. Okay. What is this one? 1 by 2 into 2b power 1 plus 1 by 2 gamma of 1 plus 1 by 2. Actually, this one, if you substitute this one as some y, okay, you will get 2r dr as dy. It will be gamma function. That's why look at it. Gamma of half integer didn't appear here. But still, that formula works. Okay, you don't have to. Okay, r into Gaussian in r. Is that okay? Speak up. R power 1, 1 by 2 into coefficient raised to 1 plus 1 by 2, gamma of 1 plus 1. Am I right? Speak up. Into 4 pi. What is this one? Minus mod a square. Okay, e square divided by 4 pi epsilon naught. Okay, into 4 pi. Gamma of 1 plus 1 by 2 means gamma of 1. That's equal to 0 factorial 1. Okay. So 1 by 2 into 2b, 1 by 4b. Speak up. You better do it again yourself, because if I do any mistake, you can't feel it. Now I'll write mod a square. What is mod a square? Pick up. Minus 2b by 5 raised to 3 by 2, okay, multiplied with e square divided by epsilon naught into 1 by 4 into b. Now expectation h, that's equal to 3 h bar square by 2m into b, okay, minus, okay, I need b power because you need to take a derivative with respect to b, then pick up. I'll write 2 by pi raised to 3 by 2, okay, speak up, into e square divided by 4 epsilon naught, okay. B raised to 3 by 2, I'll write b root b by b. Can I write like this? B raised to 3 by 2 outside divided by b. And now take dou expectation h of t by dou b equated to 0. That will be okay, 3 h bar square by 2m minus, okay, 2 by 5 e square divided by 4 epsilon naught, 2 by 5 raised to 3 by 2. Am I right? 2 by 5 raised to 3 by 2, okay, e square divided by 4 epsilon naught, 1 by 2 root b, 1 by 2 root b equal to 0. Manipulate. 3 h bar square by 2, or I will take it there, okay, 2 by 5 raised to 3 by 2 e square divided by 4 epsilon naught or 8 epsilon naught into 1 by root b, that's equal to 3 h bar square divided by 2 m. Am I right? 2 on the 2 for the, that okay? Pick up. I don't know what I did. Root b is equal to 2 by 5 raised to 3 by 2, okay, e square divided by 4 epsilon naught m by 3 h bar square, m divided by 3 h bar square, that is root b. Check this out. Tell me, somebody please tell me if I'm wrong, okay? If you are doing it yourself, please tell me if I'm wrong. Is that okay? This is root b. Expectation h at t is equal to 3 by 2m h bar square into b, that is square of that one, that's equal to, speak up, 2 by 5 whole cube k. This is the mod a square only I substituted, am I right? Where I missed? 1 by 4 5. Okay, okay. 5 should be balanced. Here 4 5 epsilon naught. Okay, somehow. That's right. I'm thinking, I mean, whether I can match with the answer or not. Okay, pick up. Pick up 2 by 5 whole cube into e square divided by 4 epsilon naught. Is that okay? Pick up. Into m by 3 h bar square, e square divided by 4 epsilon naught the whole square, m by 3 h bar square the whole square. I mean, check this out. Pick up. Minus, okay, 2 by 5 whole raised to 3 by 2 e square divided by 4 epsilon naught root b is again 2 by 5 whole raised to 3 by 2 e square divided by 4 epsilon naught, am I right? M by 3 h bar square. Check this out. Now you can take these things outside. 2 by 5 whole cube e square divided by 4 epsilon naught whole square, am I right? This is common. This one multiplied with this one multiplied with this one. That pick up. If you take it common, m got cancelled, 3 got cancelled, h bar square also got cancelled. This whole square, okay, whole square. Should not have cancelled. Am I right? What is this one? 3 h bar square divided by 2m multiplied with, okay, m square divided by 9 h bar raised to 4. Am I right? Pick up. Minus what is this one? M by 3 h bar square. 3 1 the 3 2 the, sorry, 3 3 the, m by 6 h bar square. Check this out. 3 3 the 3 into 2, okay, m numerator. What is this one? Minus m by 6 h bar square, okay. I'm not sure. Minus m by 6 h bar. Wait a second. Let me try to manipulate the last answer. I'm not sure. If any step is wrong, it would be wrong. Okay, speak up. One more time, you guys check this out. Okay, speak up. Check this out. No, I mean not from my formula list. You do it and check that out. Okay. Have you tried? minus m by 6 h bar square. Okay, 6 I can write as 2 h bar square. Am I right? 2 h bar square into 1 by 3, isn't it? Now I need again. Wait a second. So shall I rub it out everything? Expectation h minimum, that's equal to minus m by 2 h bar square. Okay, so 2 by pi the whole cube, or 8 by pi cube. Can I write like this? 8 by pi cube. I need pi here, I mean, to compare. Okay, 4 pi epsilon naught. Okay, that's why I'm going to multiply by pi square. I'm going to take e square by 4 pi epsilon naught the whole square. Is that okay? Speak up. E to 1 by 3. E square by 4 phi epsilon naught was one coefficient, the whole square, isn't it? In the Coulombic, I mean, so that's equal to, look at there, minus m by 2 h bar square. I mean, I'm just trying to write in that pattern, that's it. Okay, e square by 4 phi epsilon naught, the whole square. What is this one? 8 by 3 pi. Quite deviating. Our guess was wrong, isn't it? Huh? Right. Our guess was right. I was thinking. No, that multiple. Yeah, this is 9. This is 8. Am I right? Our guess was right. Sorry, our guess was right. This is very close to ground state, but this is little bit, what you call, less than 1. Am I right? That the quantity is negative. This quantity is little bit less than 1. 8 by 9 point something. Is that it? Pick up. So that's why the quantity is slightly higher than the ground state energy. Is that okay? Now look at here. You could have eliminated the option. Everything is three-dimensional integrals and all. Okay. Now what I'm saying is, if suppose it has a derivative discontinuity, that is the next problem in Griffiths. Check that out. Okay, he gave your trial wave function as this kind of wave function. Okay, speak up. Trial wave function. Now you can't explore any of my trick over there. Okay, you have to do expectation t. Then while finding expectation t, what you do? Speak up. Integral h bar square by 2m plus h bar square by 2m mod of dou psi by dou x dou psi t by dou x the whole square dx. Derivative you can define, am I right? If you define derivative, what will happen? Dou psi t by dou x, pick up, it will be positive here, it will be negative here, am I right? Am I right? Positive slope up to this one, negative slope. Okay. Now what you do, this derivative is a piecewise function. You divide the limit, 0 to this one to this one. But in Griffiths, he explored Dirac delta. He took second derivative. Second derivative of this one will be Dirac delta. Can you see? Step function, maybe negative Dirac delta. It is decreasing here. Okay, speak up. So he did second derivative, but you don't go for second derivative. Why do you go for second derivative? You make the method as simple as possible. You take first derivative, you take mod square of that one. First derivative is a piecewise function. You divide the limit into two parts and do the problem. Is that okay? Pick up. If your function has derivative discontinuity, you explore this trick. Plus here, okay, be careful. It is equal to minus h bar square by 2m. Speak up. Integral psi t star dou square psi t by dou x square dx. Am I right? Pick up. But the second derivative is not possible, or it can be possible only in terms of Dirac delta. Pick up. Avoid that one. You prefer this one. First derivative will be piecewise function. Be careful. Okay, you need to divide the limit while doing that. You solve the next example problem in Griffiths in this way, not in the way that he has done. Okay, pick up. That will save the time.